In this video, we're looking at combined and composite functions. So the first one of these we're going to focus on is what we call combined functions. So these occur when you combine multiple functions by adding, subtracting, multiplying, or dividing. So for example here, we have two functions. We have fx and we have gx. Fx is 3x squared plus 2x minus 1, and gx is x squared minus x plus 5. Now, the first one we want to do is y equals fx plus gx. So we're going to add these two functions. So what I'm going to do is go y equals, and I'm going to write down my fx. Now I'm going to write my fx down in a different color just so you can see. 3x squared plus 2x minus 1. And we've got plus, and I'm going to write down my next one in blue just so we know the difference between the two right now. Alright, now what we want to do is add any of the like terms. So we've got an x squared here, you got an x squared here, we've got a 2x here, an x, and then finally we've got our constants at the end there. So 3x squared plus x squared is 4x squared. 2x minus x is just going to be plus x. And then finally, negative 1 plus 5 is plus 4. So we end up with 4x squared plus x plus 4 as our combined function there. Next one we're going to look at is what if we had y equals fx gx. So when you have something like this, what it's really telling you is fx times gx, like that. Okay. So again, I'm going to write them out. So we have y equals our 3x squared plus 2x minus 1. And then we have our other function, our gx, which is x squared minus x plus 5. Now you kind of do these like you would do with any binomial expansions. You draw your arrows showing what you're multiplying. Like that. So I'll color code them just to make it a little easier. So if I go in red, 3x squared times x squared gets me 3x to the power of 4, because remember when you're timesing x squared and x squared, you add the powers. We either get 3x squared times negative x, so we get 3x cubed. 3x squared times 5 is 15x squared. We'll then go to orange. 2x times x squared is 2x cubed. 2x times negative x is 2x squared minus 2x squared. And then 2x times 5 is 10x. And then we go to our last color, our blues. Negative 1 times x squared is negative x squared. Negative 1 times negative x is positive x. And negative 1 times 5 is negative 5. Now that we've got all our multiplications out, we start to look for our like terms. So 3x to the power of 4, it was the only one. We had our x cubes there, so negative 3x cubed plus 2x, we get negative x cubed. We've got x squareds here, and x squareds here. So 15x squared. Take away 2x squared gets me 13x squared, and then we take away one more. So we end up with 12x squared. Then we look at just our x's. So here we have an x, here we have an x. So 10x plus x is 11x. And then our constant at the end is just that minus 5, so minus 5. All right, so you can have divisions of these, subtractions as well. Just make sure if you have a subtraction, so let's say we had our fx minus gx. So here we would have 3x squared plus 2x minus 1. Take away our gx, which was x squared, take away x plus 5. Remember that because we have this negative symbol at the front, all of these here change signs. So what you're really going to end up with in here is take away x squared plus x, take away 5. When you go to do your like terms, just remember that the negative does actually change all the signs in the brackets. But that's only for the subtraction, fx take away gx. The next one we're going to look at is what we call composite functions. So a composite function is where the relationship is essentially a function of a function. Okay, so if we want to find the composite function of this here, we're essentially saying we want to find f g x, where all our x's in the original fx function are now gx. So what that means is, let's say I have my x cubed here, all right? This x here is essentially changing to this here, okay? Because all my x's are now changing to gx. So what I do is just go 5x minus 3 cubed. Sometimes you'll see that they'll just say, oh, just leave that like that, that's fine. Don't worry about expanding. But let's say hypothetically we were told to expand this one, you could do it in this way. Expand one of your brackets. So if I went like this 5x minus 3 stays out the front because we haven't touched it, and we end up with 25x squared minus 30x plus 9. And then what we would do is do the same thing here. We would multiply each of these, and we end up with 125x cubed minus 150x squared plus 45x minus 75x squared minus 90x minus 27. And then you just combine your like terms, and eventually you'll get down to 125x cubed minus 225x squared minus 45x minus 27. Okay, so if you were told to expand that, here, remember when you're cubing or squaring, it's just the number of times you're multiplying the thing by itself. So in this case, we had 5x minus 3 here, 5x minus 3 here, 5x minus 3 here. So 1, 2, 3. Expand two of them with just binomial, and then do the larger one towards the end.